we're going to go ahead and find the distance between that line, which is that line that I'm sketching in blue. It has a negative slope, so that's why I made it decrease. I'm going to call it just line L. And we want to see how far point A, which is that location, is from line L. And we want to find the shortest distance. So we want the shortest path from point A to line L. To do that, we learned in class that it's a perpendicular segment from the point to the line. So just to recall, perpendicular segment is when you have two things intersecting and it forms a 90-degree angle. So what we need here is we need to know that point, that perpendicular segment, that red segment there, is from the line. So in other words, I put here point B, but we don't know the location for it. So once we find the location, I'll be able to use the distance formula to find that distance from point A to line L. So to do that, we're going to go ahead and break this process into 3 steps. Remember, the end goal is to find that distance or that length of that red segment. So step number 1, we want to find the equation for that red segment there. And we know how to write equations of perpendicular lines. So to do that, all I care about the equation of the line that they give me there for line L is the slope. And the slope, since it's in this form, will be that number before x. There's no number there, so we know that it would be 1, -1. So the slope of our line will be +1 because slopes of perpendicular lines are always the reciprocals. If I take the reciprocal of 1 over 1, it's just 1 over 1. But the signs are going to change. And then I have a point and a slope. So I'm going to go ahead and plug in my values into point slope form. So I'm going to go ahead and highlight here where each of the values would go. Remember that formula there already has a minus. So if the number after the minus is negative, make sure that you include the negative sign for the negative number. So right here we have a double negative, so it's going to turn into y plus 1. I'm going to go ahead and distribute the 1 to the parentheses. 1 times x is 1x. 2 times -2. 1 times -2 is -2. And then we want to isolate y. So I'm going to go ahead and subtract 1 from both sides. So this equation that I have here, it's what the equation for the perpendicular segment. So on here, we're going to go ahead and move on to the second step, which is finding the point of intersection. So I want to know what the location for that B is so that I can use the distance formula to find the distance between those 2 points, A and B. So there's several ways that you guys can solve a system. We have 2 equations, so we call it a system. One of them is substitution. So I'm going to go ahead and use substitution to go ahead and find that point of intersection. So notice how both equations are set equal to y. So what that means is I'm just going to set those equations equal to each other because they're equal to the same thing. So if I replace that y on the second equation with what y equals in the first equation, then I get this here. And then we're only stuck with an equation with one variable. So I'm going to go ahead and start solving for x. And because we are going to be plugging in these values into the distance formula, instead of leaving it as 7 over 2 after dividing by 2, I'm just going to turn it into a decimal. That way it's easier to work with when it's in the distance formula. We have the value for x, so now I'm going to go ahead and find the value for y, because remember, I'm looking for the location of point B as an ordered pair. So we're going to go ahead and just replace the value for x, and it can be on either equation. I just chose the second equation. So that means that the point where the perpendicular segment and line L intersect would be at 3.5, comma 0.5. So now that we have our 2 points that make up our perpendicular segment, the last step is very simple. We're finding the distance between those 2 points. So then we're going to use the distance formula. So it's point A, which was given to us in the problem. And then point B, which we found. All right. And distance formula is this whole thing here where we take the difference between the x coordinates, square it, take the difference between the y coordinates, square it, and then finally we take the square root of that value. So we're subtracting the x coordinates right now, and we're going to subtract the y coordinates. Notice how I started with point B for the x coordinates, so I have to start with point B as well when I do the difference between the y coordinates. And then we're going to go ahead and start simplifying. So inside the first parentheses, if we take that difference, we get 1.5. And on the second one, we have that double negative, so we're adding instead of subtracting. And then we just go ahead and square each of those values, which is the same thing. Take their sum. And then we're going to go ahead and take the square root of 4.5. And I'm going to give 4 values after our decimal because I want to show that we're going to be rounding to the nearest thousands. So your thousands place is that third number after the decimal. So we look at the number next to it. It's not 5 or bigger, so the thousands place will remain the same. All right, little reminder what we were doing with all these calculations here. We had a line, we had a point, point A, and our goal was to find the distance. The distance was a perpendicular segment, so that distance is 2.121. So the shortest path that I can take from point A to line L is 2.121, approximately, because we did round. And that's how you find the distance between a point and a line.